So we are now at the end of the factoring chapter, and we're going to bring everything together. So the next 4 videos are going to be review, summary, bringing it all in together. So the very first thing I always need to check when I'm factoring is you always need to first look for a GCF. Now, if you cannot visually see a GCF by looking at them, you're going to need to do the very long prime factorization lists, but that's not required. I can see that 2, 6, 4, and 12 all can be divided by 2. So I know the number 2 is a part of my GCF. Do any of these terms share a common variable? I see that they all share at least one x. So I know 2x is my GCF. So I need to divide everything by a 2x and see what I have now. So 2 divided by 2 is 1. X to the 4th divided by x gives me an x to the 3rd. So I have 1x to the 3rd. 6x to the 3rd divided by 2x gives me a positive 3x squared. 4x to the 2nd divided by 2x gives me a positive 2x. And positive 12x divided by 2x gives me a positive 6. Now you would have found these as the leftovers in the lists if you cannot visually see it. Now 2x times x to the 3rd would have given me this. If I distributed 2x to 3x squared, I would have gotten that. 2x times 2x give me 4x squared. 2x times 6 is a 12x. So you can see how you can double check to make sure you factored correctly. So that was just the GCF. The next thing, you need to look at what was left behind. How many terms are in here tells you what factoring method you are using. I see that I have 4 terms in this problem. The only way we know how to do 4 terms is to do the area model. So I am going to do the area model to this guy right here. So here's my area model. Remember, we start at the very front and we walk our way through. Now I'm looking for the GCF in this top row. I see x to the 3rd and x squared both have an x squared in common. They do not share a common number, so x squared is my GCF. After I find him, I'm going to come around and I'm going to multiply to find the rest. So x squared times x is going to give me the x to the 3rd. X squared times 3 is going to give me the 3x squared. 2 times 3 will give me the 6. So I just found my sides. So you need to have your GCF. You cannot forget about your GCF. 2 sides meant I need 2 parentheses. So this is a x squared plus 2, and he is an x plus 3, and this is because of the area model. Now you're not done. So if you think you're done, there are 2 things you need to double check. First, you need to go inside each parenthesis. Did we miss a GCF? Can I divide both of these by the same number or the same variable? Well, these don't have anything in common, so there's no GCF in here. Can I divide both of these by the same variable or number? No, so there's no GCF in here. So we checked our GCFs. Next, you need to check each of these parentheses are 2 terms. Can you actually factor the 2 terms? And remember, the only way that we know how to factor 2 terms is if it was a difference of 2 squares. So you were double checking. Are these a difference of 2 squares? He's not a subtraction, so no, he's not. So we are completely done. He is not a subtraction, so he's not. He's also completely done. So yes, you were right. We didn't have anything else to do. So this is your final answer. So this is our second review problem. We're being asked to factor. The very, very first thing you always check for is a GCF. There are 3 terms. So if you're going to do the prime factorization lists, then you need to have 3 lists. I see that 3, 6, and negative 18 can all be divided by the largest number of 3. X to the 3rd, x squared, and x all have the largest amount of 1x available. So my GCF for these 3 terms is 3x. So I need to divide everything by a 3x. So 3x to the 3rd divided by 3x is x squared. Because if you went back and you multiplied it, you would have gotten that. 6 divided by 3 was the positive 2. The x squared divided by x was an x. Negative 18 divided by 3 was a negative 6. X divided by x was just the 1, so there's no x. So we just went ahead and factored the GCF. Now we have to check how many terms are in here, because that's going to tell us how to factor that parenthesis. I see that there are 3 terms. So if there are 3 terms, you need to check to see, is A 1? Because if A is 1, we've got a really fast way to do it. A is 1. So since A is 1, that means that we know the quick double parenthesis way to actually solve this problem. So to do that, A is 1, B is 2, C is a -6. So A times C, somebody better add up to B. A times C is 1 times a -6, which gave me my -6. B was 2. I need 2 numbers that multiply together to give me -6, but when I add them, I get 2. So -1 times 6 multiply together to give me -6, but when I add these, I get 5. Well, what if the 6 was the negative? 1 times a -6 multiplies to give me 6, but when I add these together, I get a -5. Neither of those are the 2 that I wanted, so I'm going to keep going. The ones didn't work, 2's. So 2 times 3, but one of these numbers had to be negative, so either the 2 was the negative or the 3 was the negative. Multiply these together, I do get a -6. If I add these together, I get 1. Multiply these together, I do get -6. Add these together, I get a -1. Neither of them gave me the 2 that I needed. So I did my 1's, I did my 2's. I can't go on to 3's because 3 is a repeat because he's already in the list, which meant this is the full list. I cannot come up with anything else. And since I did not find 2, that means that this is not factorable, which means you're done, which means he was your final answer and there was nothing else you could factor. So our third review problem, we're being asked to factor these 2 terms. The very first thing you do is you need to find the GCF. The largest number that divides 7 and -8 is a +7. The largest amount of variables they have in common is x squared. So I'm going to divide all of this by 7x squared and find out what I had left. So 7x to the 4th divided by 7x squared gives me x squared. -28 x squared divided by 7x squared gives me a -4. If you were to distribute these back, you would have gotten the original problem, so you can double check yourself. Now we need to see how would we have factored this inside here. There are 2 terms. The only way to factor out 2 terms is to do the difference of squares. So if we could do that, remember you had to take the square root of the front, square root of x squared is x, you had to take the square root of the back, square root of 4 was 2, and it had to be a subtraction problem, which it is. So since it is subtraction, and since we could do both of these, this can be factored using a difference of squares. So you cannot forget the GCF at the beginning. Here are our 2 parentheses, one of them plus, one of them minus, because that's how you do the difference of squares. X was the answer for the front, so my fronts are x's. 2 was the answer for the back, so my back are 2's. Now, if you think you're done, you need to double check. Did you miss a GCF inside the parentheses? X and 2 cannot be divided by the same number or variable, so he has no GCF. X and -2 cannot be divided by any same variable or number, so he doesn't have a GCF. So no, we did not have any other GCFs we needed to consider. Since both of these parentheses are 2 terms, we need to check and see, can I do the difference of squares again? He's a plus problem, so he is fine, done. You can't try the difference of squares. He is a subtraction problem. Can I take the square root of that number? I cannot. So he's actually done. So we checked the 2 things you double check. Nothing ended up being able to happen. So that was my final answer, and I am done.